Hi everyone, today in Integrated Math 1, we're going to go over Chapter 12, Lesson 3. Here are the objectives. Make sure you write them down in your notes. Alright, let's go over congruent and not congruent. So here we have, while positioned differently, figures 1, 2, and 3 are exactly the same shape and size. So notice it says exactly the same shape and size. So when they are exactly the same shape and size, we're talking about congruency. That means if I cut these out, each of these figures, 1, 2, and 3, they're going to match up perfectly. However, figures 4 and 5, they are exactly the same shape, but as you can see, they are a different size. And figures 5 and 6 are the same size, but not exactly the same shape. So because of that, they are not congruent. So remember, they have to be exactly the same shape and size. It can't just be one or the other, it must be both. Congruent polygons. Two polygons are congruent if and only if their corresponding parts are congruent. So let me help you understand this. So here they're saying angle A is congruent to angle H. Notice that they have the two markings here. That is also identifying congruency. Then we're saying angle B is congruent with angle J. Notice they both only have one of those lines. Then angle C is congruent with angle K. Has 3, it has 3 here. So each of the angles, when you're comparing each of these two triangles, they match up with their angles because they are corresponding. Then we have the corresponding sides. When they are congruent, they have to be the same shape and size. So we're talking about angles, and we're talking about sides. So that means AB needs to match up with JH, which by our picture here has the one mark and the one mark here. That means they are congruent. Then we also say that BC is congruent with JK, which is indicated here as well by the two marks saying that they're congruent. Then we have AC is congruent with HK, which is marked with the 3 and 3. Because we know that all the angles and all the sides are congruent and corresponding, we can say that triangle ABC is congruent to triangle HJK. Notice the order though. The reds are first, the blues are second, then the greens are with the greens. They match up like that. It's not, the order with these ones really matters. So make sure when you're writing your congruent statement that you're matching it up. A with H in our case, which is shown here. B with J, B with J, C with K, C with K. Now we have the third angles theorem. What this is saying is if two angles of one triangle are congruent to two angles of the second triangle, then the third angles of the triangle are congruent. So they're saying, what if angle C and angle K are congruent, and angle B and angle J are also congruent? Then we can automatically say that angle A is congruent with angle L. We know 2 for sure. That means we know the third one automatically. So properties of triangle congruence. So just like our properties that we have learned, we still have the reflexive property of the triangle congruence, which means that if we have triangle ABC, that is congruent with triangle ABC. Notice the order is exactly the same. It's reflexive. Then we have symmetric property of triangle congruence. So if triangle ABC is congruent with triangle EFG, then triangle EFG is congruent to ABC. Notice the order just flops. So EFG goes up front and then ABC goes second. That's all it is with symmetric. Think about a folded piece of paper. It's going to be the same side, however the positions change. Then we have the transitive property of triangle congruence. So if triangle ABC is congruent with triangle EFG and triangle EFG is congruent with triangle JKL, then we know that triangle ABC is congruent with triangle JKL. So think about it by default here. These ones are the same. They're the middle ones and they go away. Then you combine triangle ABC and say that is congruent with triangle JKL. And there we go. Alright, so now we want to show that the polygons are congruent by identifying all of the congruent corresponding parts, then write a congruent statement. So let's go ahead and just start wherever. Let's start with our angles. Let's start with angle J. So J is congruent with, which other one is 52? It's P. So angle J is congruent with angle P. Angle K is congruent with angle, which other one is 78? It must be M. Here we go. Then we have L. Angle L is congruent with angle, so another one that has 50 must be Q. Good so far. Now let's talk about our sides. Alright, side LJ is congruent with, so another 50 must be PQ. Side PQ, I should say. Then let's do JK. Side JK is congruent with side, another one that's 39, side PM. Next we have LK. Side LK is congruent with, okay, so 40, I found another 40, must be MQ. Side MQ. Now we want to write a congruent statement. So I'm going to say triangle. And let's start with K. It really does not matter. K. Make sure you use all your all the letters in the triangle. So K, J, L, which is congruent with triangle. K is congruent with M. J is congruent with P. L is congruent with Q. And there's a congruency statement. It could have changed the order as long as the order switches with the second triangle as well. And there we go.